Before we get started, if anyone wants the slides or to follow along, there's a QR code there in the corner. It's on speaker's deck. You can also Google it. I'm pretty sure you can find it. So hi, good afternoon. Thank you for coming to the talk. I hope not to waste your time. My name is Tomel, and today we're going to be talking about on-prem deployments. Now, my clicker isn't working, so I'm going to be in the awkward position of moving back and forth to my laptop. Sorry about that. Let's start at the beginning, on-prem deployment. On-premise, right? It used to mean basically your software running on someone else's premises, namely someone else's offices, right? That means your customer's data centers or maybe an integration lab in an office. Typically, it would mean, you know, literally there's an office, there's a room, there's a server, your software is there, right? That's kind of no longer true though. So I want to expand the meaning of what on-premise is to account for that. Really, most people, most of your customers are probably not actually running their own hardware, right? No one runs their own data center unless they're Google, Facebook, whatever. Hardly anyone actually buys servers anymore. Hardly anyone even leases servers anymore. Most people just run their stuff on someone else's server, typically in some cloud provider. So really, most customers are basically running on someone else's premises, right? So a much more functional, I believe, definition of on-prem that makes a lot more sense in the modern age is my software is running on someone else's hardware, right? I don't have any control of it. It's not, you know, it's not servers I can access. It's not servers I own or that I run or that I operate. Someone else's premises. Now, on-prem is kind of a swear word, right? If you've been doing software development in the last 10, 15, 20 years or so, and your boss comes up to you and says, okay, we're seriously considering, deploying our software as an on-premise software product, you get shivers down your spine. You get afraid. You don't want to do that, right? And for very good reasons. SaaS is the norm now. Now, these reasons are still valid, right? It's hard to do on-prem compared to SaaS, but it's 2022. A lot of stuff has changed over the last few years, and I had the opportunity a few months ago of wrapping up a fairly long software development project for a client where it was literally only an on-prem software deployment project. And I've found, to my surprise, that modern on-prem deployment doesn't look anything like it did back in the day, and it's actually almost pleasant. And I figured that makes for an interesting conference talk. So that's what we're going to be talking about. Now, who am I? You don't actually care. My name is Tomel. I'm from Israel. I'm a freelancer. Mainly, I'm old. I've been in this industry for over 20 years. I've seen a bunch of stuff, worked for a bunch of companies in a bunch of ways. It doesn't mean I'm particularly smart or good at what I do, even though I'd like to think so. What it does mean is that I'm old enough to have started doing professional software engineering when on-prem was kind of the only option, then lived through 2 decades of the evolution of SaaS products, which is my bread and butter for the last 2 decades. And that just gives me a certain perspective about what it used to look like, what it looks like now, how things have changed. And that's what we'll be talking about today. So, on-prem. Why is on-prem hard? Now, obviously, I'm going to be making a lot of comparisons between modern or any kind of on-premise deployment, and the obvious point of comparison is software as a service. Right? Now, what you should probably remember is that software as a service is relatively a new concept. I mean, the whole industry is relatively new, but software as a service didn't really exist 20 years ago. Sort of the progenitors of that, things like Hotmail, Gmail, those kinds of services were kind of the first software as a service offerings on the market. They're not that old. They're 2 or less decades old. So why is it hard? What is the fundamental difference between on-premise deployment and SaaS? Well, it boils down to these 4 things that are listed by order of how important they are to your mental health as a software engineer. To start with, the release process, right? whatever it is you're working on, if it's a SaaS product, like presumably most of us are working on, the release process tends to be incredibly simple, right? You commit your code, you do some testing, you run, tests run in your CI server, you hit a button somewhere. It might be a little bit more complicated than that, but fundamentally, you have a feature, it's done, it's in, your master branch, you hit a button, 5 minutes later, it's available to your customers. The release process is super simple. For on-prem, the release process by nature has to be more complex. You have to, you have to package your software artifacts. You have to have documentation, release notes. You have to coordinate the releases with other groups and with your customers, right? So fundamentally, it's a much more complex process. In terms of how much control you have over the environment your software runs in, obviously for SaaS, you can choose everything. You want to run in the cloud, on another cloud, you want to run Linux, Windows, whatever it is you want to do, it's under your control. For any on-prem deployment, your control over the running environment is very, very limited. It's basically the requirements you provide your customers when they're installing software, and that's kind of it. You don't really get to control much else. This is where things start to get gnarly. How many deployments, how many versions of your software do you actually have running out there in the field? For a SaaS product, you typically have a very, very small finite set of versions, right? You typically have between 1, maybe 2 or 3 versions, right? You have your production environment, you might have a staging environment, you might run canary deployments, but we're talking about between 1 and 3 concurrently running versions of your product, which makes it very simple. Now, when you can't really control when a new version of your software is deployed by a customer, you can potentially have as many concurrently running versions of your software as you do clients, right? You have 10 clients, you might be running 10 different versions. That makes it incredibly complicated to support, and obviously affects the way you do software development. And really, the most difficult element in on-prem deployment is the staff, the people that are actually running, installing, and operating your software. Because in a SaaS model, the people are in-house staff, right? They're your ops department or however it is you're set up in your organization. Point is, they're your people, right? They're incentivized the same way. Whereas with on-prem deployment, the people that actually operate the software have completely different incentive structures. Basically, they just want the software to work and be left alone, right? So the challenges in on-prem deployment can basically be summed up as one category of challenges, which is coordination. Coordination is hard. We all know that, right? Conway tells us that. Experience tells us that. Anything that requires 2 or more people to coordinate in order to get a job done becomes that much harder. And all of the challenges around on-prem basically revolve around this point. Which begs the question, why would you even do that? Why would you do that to yourself? Why would you run on-prem if SaaS is an option? Well, we all love SaaS. We've been doing SaaS development for years and years and years. It's a wonderful and simple and easy model, but it's not really always an option. So in some cases, depending on the domain you're in, you might not even be able to do SaaS. So for instance, you might have regulatory concerns, right? You might be in fintech, or you might have, you might be building software for a medical device, right? SaaS really isn't an option in some of these cases. You might have security considerations. So for instance, if your software is the control software for a nuclear power plant, hopefully that's not connected to the internet. Hopefully. Otherwise, you'll be in trouble with the Russians. You might have physical constraints, right? If you're building embedded software, if you're writing software for a pacemaker, for instance, there is no as a service, right? That's just not relevant. And then there are the other reasons why you might have to end up doing on-prem deployment, like if you actually sell infrastructure, right? If the software you're building is a microcontroller for a hard drive, obviously by definition, that's not really a practical option to run on a cloud somewhere. And then some people are just reticent to buy SaaS software for reasons. There might be good reasons, there might be stupid reasons, but you want to sell your software, and your customers dictate what they buy. So it's not really up to you. So there are various reasons why you would have to deploy your software on-premise. And if you're in that situation, well, I have some news for you. When we consider the recent history of software engineering, when we consider how we build software and how we've evolved in the way that we build software over the last 20 years, we find that a lot of the kind of new tools that we have at our disposal are tools that were kind of built to support the new SaaS ecosystem. So it's things like virtual machines and hypervisors, public clouds. Public clouds are amazing for SaaS. Container environments. So Docker is a packaging paradigm, as a tool for software deployment, evolved to support basically mostly public clouds. And obviously container orchestration, which is built on top of the containers themselves. So things like Kubernetes or Nomad or whatever it is you want to use. All of these are new-ish tools that have evolved over the last 2 decades or so that just didn't exist before that, right? They were not an option. And the question is, can we leverage these tools to enable us to do on-prem deployments better, faster, more efficiently, etc.? And obviously, the answer is yes, otherwise I wouldn't be here talking to you. Now, before we get into the actual tools, before we get into the actual concerns around on-prem deployment, we need to consider a few kind of leading questions, leading characteristics of the software system that we're building that will dictate the level of complexity and the level of convenience that we're going to encounter as we build and deploy those systems. So not all on-premise software projects are created equal. There are varying levels of complexity, and there are 4 major kind of design constraints that you have to know ahead of time in order to know how to put together a workable, acceptable solution for your deployments. And the first is data persistence and retention. Does your system even have to store data? This might sound like a weird question to ask, what kind of software system doesn't store data? But if you think about it, a lot of software doesn't need actually persistent data. So if you're building a load balancer, for instance, it might not need to store any data, right? If you're building some kind of security appliance that analyzes inbound traffic for whatever, maybe it doesn't need any persistence layer, right? So if you don't need persistence, it makes your life a lot easier. But most systems do need permanent storage for whatever it is that they do. Then there's the question of, the actually really big question of, does your software system need to run on a cluster or in multiple hosts? Can it run on just one machine? And it turns out that specifically for on-prem deployments, this is actually a much more important question than you might think. There is also the question of where is your system going to be deployed, right? If your customers are running on a cloud somewhere, then there are certain advantages and disadvantages to that for you as a software vendor. On the other hand, if they're running in a co-located environment, which is old English for renting servers in someone else's data center, that also has ramifications on your design. And finally, there's the question of networking, which is to say your software is installed on a server somewhere. Can it actually talk to the external world, right? Can it access servers? Can it download stuff off of the internet? Can it send telemetry? There's all sorts of stuff you might need or want network connectivity for, but you don't always get to have it. That is also a very important design constraint. Once you have reasoned about these 4 elements for your particular system, and we'll discuss an example of that in a minute, you can actually start putting together the tools that will help you provide a useful and workable environment for your clients. Let's talk about those tools, right? What new tools do we have, or what tools have evolved over the last 20 years that really help us support an on-prem deployment in a way that's really convenient for our customers? Now, a bit of full disclosure, I haven't done any professional development under Windows for a while now, so this is kind of Unix centric, but really the principles apply just the same. So some of these tools might not be as popular in the .NET or Windows spaces. You would know better than I. So apologies in advance if they don't seem to apply, but again, it's the principles that matter, not the actual tech. First tool in our tool belt that did not exist 20 years ago and makes a world of difference is Docker. Now, at this point, Docker is not news to anyone. You must have heard 1,000 different conference talks about Docker. It's probably coming out of your ears already. No one wants to hear about Docker anymore. It's kind of a given. But in this context, Docker is actually, I feel, a dramatically more powerful tool than it is for SaaS software deployment. Because what Docker provides to you as a software developer is it gives you a consistent way to package your artifacts. So whatever it is that you're building, there's a nice envelope of tools around it. There's consistent operational models, consistent lifecycle, right? The same commands are used to get at your artifact through a registry or a repository. There's the same set of commands to start and stop and remove and kill and manage storage and all of those things that you might need to do. And most critically, if you package your software components as Dockerized containers, this actually turns out to not just be useful in the general sense, but it also composes really well with all of the other tools that we're going to be discussing today, and it's reusable in all scenarios. So if you package with Docker, that's useful for development, it's useful for testing, it's useful for production deployments, it's useful for all sorts of production deployments. It's just a really, really nice environment to be working in compared to if you put your minds to 10, 20 years ago to getting MSI installers and Linux shell scripts and what have you to actually set up your software locally on a customer's server, which is madness. Docker makes all of that very streamlined and a lot easier to work with. Then there's a few other tools, like my personal favorite, Docker Compose, which is really a tool that doesn't get a lot of love at all, although it's actually incredibly useful if you need to run a multi-component setup. And let's face it, most software has more than one process, more than one moving part, more than one executable that you need to manage. If your system fits within a single host, within a single physical machine, then Docker Compose actually gives you a really, really, really nice lightweight way of packaging all of those disparate components into one cohesive whole that you can then deploy. So dead simple. Really nice tool, doesn't get a lot of love, but it is very useful for on-prem deployments because it also composes really well with the next tool that we didn't really have 20 years ago, and that is virtual machines. Now, virtual machines and virtual machine images are a truly awesome tool for deployment. Whereas 20 years ago, you would distribute your software as either a downloadable ISO image or a physical CD or DVD that your customers would then put into the server and use an installer to set up. Nowadays, you basically provide them with a machine image. Like, this is what I need you to run on your server. I don't care how you do it. Here's the file, here's the VHD, just run it on your server. And this is a very convenient way of deploying software because it's self-contained. You can basically provide a server that's fully configured. It's got all the initialization stuff, all the security stuff ahead of time, gives you a very consistent deployment model, and critically, everyone can run virtual machines. Whether you're running in the cloud, whether you're running on a, some sort of old school virtualization subsystem in a data center somewhere, your clients, more importantly, can run your virtual machines in a consistent way, and it's really, really easy. So that's a really, really useful tool to have in your toolbox. And you can also, if your customers are running on public clouds, which a lot of them do, and as I mentioned before, that can be considered a form of on-prem, you can also actually publish your software as a virtual machine image in the respective cloud provider's marketplace, which is an incredibly easy sell for customers. Once they can actually go into the marketplace and with a few clicks get an instance of your system, that is a really, really good, pleasant way to deploy your software. Next, we have container orchestration, or Kubernetes. Okay, basically private, modern containerized private clouds. It doesn't matter if it's Kubernetes, Nomad, it doesn't matter if it's managed or not. Fundamentally speaking, if your software system that you're providing to your customers has to run on multiple machines, these types of systems, these types of container orchestration systems are your best bet at actually providing and delivering that value to your customers, because they make it a lot easier. Like if you can provide a Helm chart or a CloudFormation template or something of that nature that fundamentally packages multiple components running on multiple machines as one coherent deployable thing to your customers, that's a win. However, that's also a much, much, much more complicated and complex deployment model than the single machine one. So really, if you have to run on multiple hosts on-prem at your customers, it's going to be hard. There is no silver bullet. And honestly, if you're in that space, you probably don't need the stock. You probably already know most of the stuff I'm talking about here. So this is a big subject. And it requires, I can easily spend an hour talking about how to do that, but we're not going to go into that. Now, your customers may or may not be running on a public cloud. If they are, that's a huge benefit to you as a software vendor, even if you don't run your own software. Even if you run on-prem, but on a cloud somewhere, that gives you an amazing set of tools to work with right out of the box. So for instance, a delivery mechanism, as explained before. If you're running on AWS or Azure, there's a marketplace for virtual machines. It makes it that much easier for your customers to actually get up and running with your software on their own designated public cloud. But more importantly, it also gives you a lot of integration opportunities that are actually really hard to get to as a software vendor. So for instance, if whatever software you're working on requires access to customer data, and a lot of them do, and your customer is already running on, say, AWS or GCP or any of the public cloud providers, those come with their own identity management subsystems and security subsystems and access control subsystems that your prospective customers are already bought into, right? You don't have to work very hard to provide a secure and a secure path to your customers to actually provide you with access to their data, because it's already built into the platform that they are running on. That makes it a much easier sell. So if you're in a pre-sale meeting with a customer, you're trying to sell them on your software as a vendor, the tricky thing is always coming up with a way to explain how your system integrates with their existing systems in a secure way. And if you can just say, oh, we're leveraging the same tools that you do, like you need an IAM role, you need these permissions, it just becomes a much, much easier conversation to have. You also get to leverage the services that those cloud providers provide. So if your system comprises, say, MySQL or Postgres or any database subsystem, operating that is a burden. Your customers don't want to have to mess with MySQL if it's outside of their realm of knowledge. But if they're already bought into, say, AWS, and I'm going to use AWS as an example, but it's not a preference. The same is true for any cloud provider. If your customers are already running on AWS, then setting up another instance of RDS is trivial. and it's a trivial SIL. It's not a big operational burden for them. So that gives you a lot of opportunities to leverage tools that you would otherwise just not be able to use because you can't put that operational burden on your customers. That is a pretty sweet deal for you. Also, you get a lot of regulatory concerns and service level concerns that are provided by essentially a much bigger company that their business model depends on operating these things, right? Amazon make their money from, for instance, selling MySQL instances through RDS. And they take it upon themselves to deal with things like on-disk encryption and various compliance issues. All of these things are provided to you as a software vendor by that third-party cloud provider where your customer is already bought in, right? They're already running on that platform. You don't have to convince them that this is a sensible way to go. And that is, that as far as a sales pitch goes, again, saves tremendous amount of time, but more importantly, it means you can leverage these tools, whereas 10 years ago, you might not have been able to, which is great. There's also a plethora of monitoring tools that we didn't have 20 years ago. So all of the third-party SaaS monitoring tools that you might be using, whether it's for centralized logging, whether it's application performance monitoring tools, whatever it is that you end up using, hardly anyone nowadays kind of runs these types of tools or manages these types of tools by themselves because it's hard, right? It's a much easier sell if your customers are already using one of the very common third-party, say, logging and metric services, whether it's, some common examples include Logs.io or CoreLogix or even CloudWatch. All of these tools you can leverage for your own benefit in a way that is a lot more accessible and a lot more acceptable to your customers, right? If you can save your logs to, say, CloudWatch, you also enjoy the privilege of being able to offer a secure logging environment to your customers, and your customers can then provide access to you in a way that's fully auditable, that's compliant. It just smooths out the whole issue of how to operate your on-prem product when it's actually running on someone else's premises, and it makes it a much easier sell. Now, if you can't leverage these tools, there are other opportunities as well that we didn't have 10 or 20 years ago. So if you can't call home, like for instance, if your design constraints are such that your system, wherever it is, has to run in isolation and is not allowed to call to external services and telemetry, talk to a licensing server, any of these things, there are still tools and opportunities that help you out that make it a lot easier. So if you can't, for instance, use any of the third-party telemetry platforms and logging platforms, then really there is no substitute for good logging. There is no silver bullet, and good logging comes out of experience. Like there's no easy way to get good telemetry out of a system without working at it. There are no silver bullets. But some of the tools actually help you mitigate the pain of diagnosing a system running on someone else's prem. So if you're on a cloud and if your customers are running on a cloud provider, they are very likely to be okay with your system, for instance, storing logs on, say, S3. And then if your logs are stored on S3, it doesn't mean they're accessible to you. It's still running on your customer's account. You don't have access to it unless they provide you with access. But because it's all fully integrated in, with the set of security and compliance tools that AWS offers, that means that unlike the sort of deployments that you would get, again, a decade or two ago, your customers can, with a few clicks, actually provide you with fully audited, fully secure access to the logs, making it that much easier to debug and reason about your system, even if it's running on someone else's premises. Modern communication tools, Zoom, Google Meet, whatever it is you use, are also amazing support tools in that your customers can actually provide you shall we say, controlled access to the system by way of literally being on a call with you and letting you have remote control so you can operate your systems in a way that's safe and secure for your customers. So that's acceptable to them. If you've had the experience of not being able to access the server running your software or accessing the logs for your software just because it's running on someone's server somewhere, this is a pretty fascinating experience, because suddenly you can basically sit down, like virtually sit down with your customer on that, on that server, on their hardware, in a way where they see everything you do and they can shut off your access with a click of a button. Everyone feels much safer doing that. So that actually lets you get the diagnostics you need. It lets you gain access to those servers. It lets you do administrative tasks on those servers in a way that's acceptable to your customers, which is something that was simply not possible in any way a decade or two ago. So that was kind of a bird's eye view of what's changed. Now let's talk examples. So, as I mentioned before, last year, I spent most of last year working with a particular customer on a product that was an on-prem product. Now, unfortunately, that product is defunct. It didn't find a good product market fit, and the company folded. So that's a shame, but on the other hand, it means I get to talk about it, and I don't really have to, fudge anything or hide any details, because the company doesn't exist anymore, and I have permission to do so. So let's call it Product X. It's really called CloudKeeper, but when I wrote the slide, it was still kind of up in the air whether or not I'll be able to use the name. So let's call it Product X. Product X is a security product. It does log analysis and security scans and anomaly detection, all of these wonderful things that modern security systems do. Critically, though, it is a multi-component production system, mostly built in Python. It uses a bunch of components of the type you might use on your SaaS products. So we used Redis for caching. We used Postgres as the backing data store. We had a full-blown web application as a static front-end bundle or client-side bundle. We had some external integration points, all of the things you would have in kind of your run-of-the-mill production service. Now, critically though, this product had to, by definition, run on-prem, because the sort of clients that needed it had a bunch of data that they wanted to feed through the system and gain value out of that data. But it was a very security-conscious environment. So we had a few design constraints that are kind of unusual and also kind of preclude SaaS deployments for our the sort of customers we had anyway. So the customers themselves were typically running on a public cloud. We had customers running on AWS, customers running on Azure, but said customers wanted CloudKeeper or Product X to run in complete isolation. So we as a vendor did not have any access to customer data. Our software components could not call home, so we couldn't send telemetry out, we couldn't send logs out, we couldn't contact any third-party service, including our own, without a very, very strict protocol of how to gain approval for that from our customers. And possibly the most difficult element of it is that the team that actually made use of the product was not a technical team. It was a team of business analysts running, there were a bunch of customers. Each one of them had their own typical business analysis team. Now, these are not technical people. They're not stupid, but they're not technical people. Their job is to crunch data. They work in R. They don't, R being, the statistical language. They're not computer people, they're not very tech savvy, and critically, they're not even empowered to make operational decisions or technical decisions within the company. And typically, they would have a separate ops department that was not particularly cooperative, right? Getting a server to install our software on was hard. Getting SSH access to a server was pretty much impossible. That's what we had to work with. So the teams that were actually owning the deployments were large teams that wanted the product but were not tech savvy at all and did not have the how should I put this? They didn't have the organizational backing to make technical decisions. So it was a very, very limited environment to work in. The choices we made, to start with, we did decide to run on a single host because the sort of data crunching that the system did was not at a huge scale. We could avoid having multiple components running on multiple hosts, at least to start with. So I ended up with single host deployments using Dockerized components, Docker Compose, running, everything was defined with a single Docker Compose file, whether it was our various components, Redis, Postgres in some cases, although we ended up leveraging the cloud infrastructure for that. And critically, we had the same package for all use cases. So the same Docker Compose file was used for development, internal development, was used for our testing, whether it was testing on a developer's laptop or more full-scale testing with a demo system on a dedicated AWS account. And the same file was actually deployed on customer servers within their cloud account. And that very fact, the fact that we could leverage the same infrastructure, the same tools in all of these use cases was fantastic. Like it made everything really, really nice and easy. We offered our product as a virtual machine image that was actually listed on both AWS Marketplace and the Azure Marketplace as literally a virtual machine image you could just set up an instance of in a few clicks. We leveraged the various cloud providers' RDBMS services for Postgres. So our customers didn't have to manage Postgres at all. They didn't have to know anything about it. Although they did have to set up RDS or whatever it was on Azure. Sorry, I don't remember the name of it. But the nice thing is we got full-blown management, availability, compliance, end-to-end encryption, all of these things provided by Amazon or Microsoft in a way that we could leverage but didn't have to do any work. And our customers were super happy about that because, again, they had assurances of availability, of compliance, all these things by massive companies, right? It's not some fakakta small vendor that no one really has ever heard of that's managing their production critical data and just promising availability and security. These are battle-tested systems running much larger corporations in a way that is fully regulated and fully compliant. So everyone was really happy. We used Packer to generate these machine images. If you're not familiar with Packer, it is basically a tool where you define your virtual machine image as a set of metadata and builder steps. It's machine image build tool, if you will. Highly recommended, even though it's a little finicky. Targeting an older version of CentOS because that's just what was required by our customers. So these are the choices we made in light of those design constraints. And it worked quite well. Notably, things that worked very well are the setup process. So one of the most amazing things about putting all these tools together in this way was the experience of sitting in a demo meeting, a pre-sale demo meeting with a client and showing them how with their own AWS account, within 5 minutes and a few clicks, we can actually set up a working instance of our system in their account without any interaction with operations personnel, without any technical know-how. We could just sit down with them over Zoom, because COVID, and just show them how to set up our system not even as a demo. It's like, okay, we're up, right? A few clicks, you need to configure these things, done. Your system is there. And that's the sort of experience you generally expect from a SaaS product, right? That's the sort of experience you get from a self-serve, full-blown, modern-day SaaS product. You didn't use to get those from on-prem products back in the day. What you would have is you would have a demo meeting with the CTO that was carefully orchestrated so that it's running on a demo environment and we're just showcasing some stuff. The CTO is happy. They send their ops personnel to talk to us. There's a lot of back and forth. 3 months later, maybe we have a server installed somewhere for testing and evaluation. Right here, we had a production environment up and running within minutes, and that was just unbelievable. Also, that production environment was fully integrated with the customer's own security practices, identity management. It was secure in that it was not accessible to us. It made the customers very relaxed and very confident about the setup of our software on their premises. Which is really, really quite amazing compared to my experiences from, say, 2 decades ago. Upgrades were also very trivial, basically because ironically, we had full control over the machine, even though it wasn't our machine, it was not running under our account. Because we could set it up the way we wanted to, it was a virtual machine image. It was fully set up with Docker Compose. So an upgrade basically meant we upload a new Docker image to ECR in our case, or the Azure registry. We instruct the customer on how to upgrade it, which is one command to run a script. They knew full well what it meant. It's like, okay, for the upgrade, what you need is you need access to ECR, and you need to approve this one-time interaction with not even a third-party service, but actually a built-in service within your cloud provider, which again made our customers very secure and very easy about the whole process. And just from an experiential standpoint, it was super trivial to upgrade to new versions. And if you've ever run on-prem software, especially back in the day, you know that upgrading is never an easy process. Generally, you would get, again, a CD or a DVD or an ISO image. There was a whole process about how to upgrade. It involved multiple teams. It was always a mess. Here, we could provide them with an experience that was almost as streamlined as a SaaS product, except, again, running on their own hardware in their own AWS account or Azure account or whatever. And little or no technical know-how required. The team, as I mentioned before, a team of business analysts, not very technically savvy. Other than that very, very initial interaction with our ops team to explain to them what is required in terms of how to actually set the thing up on their AWS account, we had zero interaction with our ops team beyond that. And that just made things a hell of a lot easier. Now, there definitely were some challenges on the way, and it's worth talking about at least 2 of these. The first challenge is that integrating all of these tools in a coherent way that actually works takes a certain amount of expertise. Whether you call it ops, DevOps, or SRE, it doesn't matter. Right? We're integrating a whole bunch of tools, including Docker, systemd, machine images, AWS accounts, AWS services, or Azure, or whatever. That requires a lot of operational expertise. So, pardon. So we needed, the people that actually put the product together had to either have this expertise or develop it. And a lot of the work in terms of producing the deliverable, right? There's the system code, there's the Python code that actually does the work, and then there's a lot of stuff around that. There's a whole envelope of tools and glue logic and scripts and setting up stuff on our Amazon account and publishing to the marketplace. There was a lot of operational work around that had to happen. So however you do on-prem, you can't really get around that. You're gonna need this kind of operational expertise or to develop it. So that's something to take into account. supporting the system and getting diagnostics on the system, debugging it, figuring out why things wouldn't be working in case they weren't, dealing with bugs, all these things, there's no way around it. It's much, much harder with an on-prem product, even with these modern tools. That's a legitimate challenge. We were not allowed to use third-party telemetry services. We had no direct access to our logs. We had no direct access to the servers. We could not open a terminal to a server and start debugging the system. We had no access to the databases. So the question is, how do you support a system in that way? Again, no silver bullets. Based on a lot of experience, we added telemetry to the system. We instructed our clients on how to, on what that telemetry is and how to provide access to that telemetry. And we leveraged the Zoom remote control feature quite often when we actually had to help our customers out of a situation or to figure out a bug or any of these things. It wasn't as terrible as you'd expect, again, because a lot of the modern communication tools just make it a lot easier. And because customers are quite content to sit there on a call and let you have remote access when they know it's not you having permanent remote access. It's actually the identity of the person on the team at the client that is letting you have control. So the mental equivalent is you come into their office, they set up a computer, and they just let you have the keyboard while staring over your shoulder, right? That's basically the process, but it's hard, right? There's no way around it. So, in conclusion, the sort of tools that have enabled the SaaS ecosystem to grow over the last 2 decades are, I would argue, actually more useful for on-prem deployment than they've ever been for the SaaS ecosystem that they were built to support. Public clouds are incredibly compelling on-prem targets. So if you do on-prem deployments and your customers actually do run on one of the common public clouds, you're in luck that you're going to have a really good experience. Virtual machines in Docker really make the deployment element of it, the mechanics of deploying on-prem software, they make it almost painless. And that I think was the most surprising thing to me compared to kind of what I was used to. And supporting it is surprisingly easy, especially if you can use third-party observability tools. So if you can send logs to a centralized logging service, if you can send telemetry, if you're allowed to send telemetry back to your servers or even a third-party logging infrastructure, then that makes it a hell of a lot easier to support than you would have expected. In short, on-prem is harder than SaaS, right? There is no way around it. It is a much more difficult deployment model to work in. So if you can do SaaS, you should do SaaS. If you can get away with not providing any sort of on-prem option for your software, your life will be easier. You definitely should go with that. But if you have to do on-prem, it turns out that the modern tools actually make it a much better experience than you think. So there's really kind of no need to be afraid of it. If you are in the position where you have to provide on-prem deployments to your customers, then that is not a bad position to be in. 10 years ago, you would have been right to avoid it like the plague. Not that plague, the other plague. But if you're in a position where that's what you have to do from a business standpoint, then it's actually rather pleasant. It's actually a fairly good story, and you have really, really good tools to help you out. So don't be afraid of on-prem. It's not what you've been told. It's not what you may remember if you're old enough. It's actually a pretty nice world we live in today with modern tooling. And with that, if there are any questions, I'll be happy to take them. And if not, then have a great conference and a good day. Any questions? Yep. So just repeating the question for the camera, the question is, can I explain a little bit what I mean with public cloud in the context of this type of software deployment? So what I mean is, as you said, basically your customers are running stuff on, say, again, I'll use AWS simply because it's easiest for me. That's the most recent cloud I've been using. If your customers have an AWS account, they're running infrastructure on AWS, they're running software on AWS. It means they're already bought into all of the AWS stack, right? They're probably using IAM for identity management. They're saving data to S3 or RDS instances. On-prem deployment on a public cloud in this case would mean you provide them with, say, a virtual machine image that's available from the AWS marketplace. And when they set it up, it spins up EC2 instances or various cloud resources under their account. It's not you as a software vendor that spins up these resources. It's their account, their resources. You're not even, you don't have access to it. You're not familiar with it. What it does mean is that your software running under their AWS account can also leverage the AWS resources and identity management, all that stuff that their account leverages, right? So you can integrate with their identity management. You can potentially, if they allow you to, you can read data off of their databases on RDS, off of their blobs on S3. That's kind of what I'm getting at. It means that their premises is basically in a namespace in AWS, and you get installed there with the resources that are on offer. Hope that answers the question. Any other questions? Okay, thank you very much. Have a great day.